In this video, we're going to talk about the net change as the integral of a rate. And we have a theorem that says we have the integral from t1 to t2, and of course t1 and t2 are just your x intervals, okay? Always make sure that t1 is your lower bound and t2 is your upper bound. S prime of t, remember that prime means the same thing as derivative, which means the same thing as slope, which means the same thing as a rate of change. So this part right here just represents an ROC, a rate of change, okay? And then this part over here says that once you integrate, your answer is going to be whatever you get with S of t2 minus S of t1. And another way to look at this is that the left-hand part of this is the integral of the rate of change, and the right-hand part is our net change. So we're going to take a look at a couple examples to see exactly how this works. So here's our first example. It says water leaks from a tank at a rate of 2 plus 5t liters per hour, where t is the number of hours after 7 a.m. How much water is lost between 9 and 11 a.m.? There's a couple key pieces of information in here that we need to pay attention to. First of all, the two words leaks and lost lets us know that this function needs to be decreasing. So the function that it gives us, the rate part, this guy right here, it needs to make sure that we have this negated. Okay, so we're going to have to make sure that there's a negative sign that's going to go with this function. Otherwise, it's going to represent something that's increasing, which is not the case here. The other thing is something that we already pointed out, but the rate part, which if we look back at our function, or our formula, that's this part right here. Okay, that's our rate of change. So that's where that's going to go. Okay, and then the next part that we have is this 9 and 11 a.m. That's obviously going to be our interval. This is going to be our T1 and our T2 values. However, there's something really sneaky in here. It's saying that all of this is occurring after 7 a.m. Which means, if I make a little table here, that when it's 7 a.m., that's when t is equal to 0. Okay, so I'm not going to use 9 and 11 in my integral. 8 is t equals 1. 9 is actually t equals 2. 10 is t equals 3. And 11 is t equals 4. So the two numbers that we're actually going to need are t equals 2 and t equals 4. So to get this set up, what we're going to do is we are going to get our integral set up. So here's our integral, and we're going to put 2 on the lower bound and 4 on the upper bound, and we're going to put our negative in front of it so that we know that this function is decreasing. We're going to put our rate of change in here, which is 2 plus 5t, and then we have a dt with it. And after this, we're just going to integrate. So the integral of the 2 is going to be 2t, okay, because there was a t to the 0 power next to it, okay. Any constant always has that with it. So when we add 1 to the 0, it just becomes 1. So the next part is we have plus 5t, and then it already has this to the first power, so when we add 1 to that, it's going to give us a 2. And then we divide this by 2. We're going to close this up. That's the end of our integral, but don't forget the negative sign that was on the outside of that first. So I'm going to put that right in there. And of course, we're going to use our vertical bar notation here to let us know that this is from 2 to 4. So we're going to plug in 4, and what we should get there is negative 48. And when we plug in 2, we're actually going to get negative 14. And when we combine these two, it's going to give us a change of negative 34. And remember, this is a net change, right? It's the difference of a unit. What is the unit that changed? And in this case, it's liters. So we lost 34 liters between 9 and 11 a.m. Okay. So the next example, we're going to say that the number of cars per hour Passing an observation point along a highway is called the traffic flow rate Q of t. So there's two parts to this question. The first part is which quantity is represented by the integral from t1 to t2 of Q of t dt. So here's the thing, Q of t is a rate, right? We've already established that. This is in cars per hour. So after we do the integral here, we should have an amount of one of these things, and we're not going to have an amount of hours. We're going to have the amount of cars. So the way that we can say that is like this. So we can say that it's the total number of cars that pass the observation point during this particular time interval from t1 to t2. Using the word total is really helpful. Even in the previous problem, when we look back, this is the total amount of liters that were lost between the hours of 9 and 11 a.m. In this particular problem, it's the total number of cars that are going to be passing this observation point. Okay, so the second part of this question uses a table. And the top part is time. This is from 7 a.m. to 8 a.m. And Q of t is the rate of the cars going through per hour. Notice that this is in 15-minute intervals, and the question is to estimate the number of cars using the highway during this 1 hour period. And the strategy that we're actually going to use is not a right or a left-hand sum or even a midpoint sum. We're going to use trapezoidal so that we can get the best approximation. So the way to do trapezoidal sums without even drawing a picture is by carefully looking at the values within our table. So first of all, the formula for the area of a trapezoid is 1/2 times the height of the sum of the bases. And when we take a look at a function, okay, let's say that this is our function, just for the sake of argument, and we make a trapezoid out of it. So let's say I pick from here to here. There's a trapezoid. The bases are actually the parallel parts, this side and this side. And their heights are going to be denoted by the y values right here at those points. So within the first two intervals in our table, this is going to be my base 1, and this is going to be my base 2, okay, because those are the y values that go with that. The height part is actually, when you look at the picture, kind of like the width, okay, because the height of a trapezoid is from the parallel sides. So the height here is actually the difference in time, which for every single one of these trapezoids that we're going to make is 15 minutes. So we're going to set this up one trapezoid at a time, and we're going to add up all of our areas as a Riemann sum. So to start this, we have the 1/2 that's already in our formula. And our height, although this is 15 minutes, remember that this is in terms of hours. So what part of an hour is 15 minutes? And that would be a quarter, or 0.25 hours. That's going to be really important. Now what we can do, since all of my time intervals are all in 15 minutes, we could only have to do this part once. We're going to add up all the different bases in a huge bracket. So we are going to add together the first two bases, which is 1044 plus 1297. That's going to be for the first trapezoid. Then we're just going to keep adding the other bases to it. And by looking at this, I don't think this bracket's going to give me enough room. So we're just going to keep on going. So the next trapezoid is going to be built off of the second and the third interval. So that's going to be from 1297 plus 1478. And then we're just going to keep on going. Plus, and then my next trapezoid is from the third to the fourth interval. So that's 1478 plus 1844. And we're just going to keep on going. And then the last one is going to be the fourth time period to the last, which is 1844 plus 1451. And then we're going to close our bracket, and we're simply just going to calculate this. And all of this gives me approximately 1,259.125, an eighth of a car. So we can easily just say that this is a rough estimate of 1,259 cars, because we can't have a fraction of a car going through this checkpoint. And the checkpoint is like a toll, like on our toll roads here. That would be kind of like an observation point. And so this is the total number of cars that passed through between 7 and 8 o'clock a.m. And that will conclude this tutorial.